Hi everyone, my name is Jakub Staroń, and this is the next episode of MedChem Essentials, scientific seminars devoted to medicinal chemistry. Today, we continue talking about solubility. The topic of today's presentation is recommendations for simulated body fluids. We'll begin with the recap on the topics described during the previous presentation, then we'll move to the selection of appropriate pH and selection of bile salts and phospholipids. During the previous presentation, we introduced different simulated intestinal fluids both for the fasted and for the fed state. We described how they differed in their pH and concentration and ratio between bile salts and phospholipids. We also described how different compounds, depending on their nature, whether they were neutral, weakly basic, or weakly acidic, behaved in different simulated intestinal fluids. And here we found out that these compounds showed either underestimation or overestimation of the measured value as compared to the actual solubility in the human intestinal fluid. Quite rarely, we saw accordance between the measured values, and often this required modification of the parent media by some additives, ox bile salts, for instance. Let's move to the discussion about pH. If our compound is weakly acidic, it will show low solubility in acidic stomach and higher solubility in small intestine. If our compound is weakly basic, it will show high solubility in the stomach and lower solubility in the small intestine. The variability can be much less for weakly acidic, so within the gastric range between 1 and 3, the saturated concentration for a weak acid is estimated to be relatively constant for drugs with pK above 2.5. For weakly basic compounds, the concentration is expected to vary around twofold for this weakly basic of pK above 1. For stronger bases with pK above 4.5, this concentration is expected to vary even 100-fold between pH 1 and 3. So concluding, pH variation is much more impactful to solubility and dissolution rate for weak bases as compared to weak acids. Concluding, it is recommended to test weak acids in a dissolution medium representative of a small intestine, since quite limited relative extent of dissolution is expected to be found in the stomach. Whereas the testing of weak bases is recommended to be done in sequential gastric to intestinal dissolution mediums, since quite high relative extent of dissolution is expected to be found in the stomach, which is followed by even supersaturation or precipitation in the small intestine. These simulated intestinal fluids are characterized not only by their pH, but also by the composition and presence of bile salts and phospholipids. Before we go further, it is noteworthy to mention that together with cholesterol, they form lipid aggregates. And the composition, size, and form of these lipid aggregates can vary significantly between individuals, which is found in the aspirated fasted state human intestinal fluid. These lipid aggregates, they have the potential to significantly increase concentration and therefore rate and extent of dissolution. To what extent? If the volume of fasted state intestinal fluid lipid aggregates, this vesicles, is about 0.1% of aqueous volume, then 1000-fold partitioning into these structures will enhance solubility by at least twofold. For lipophilic molecules of log D greater than 3 and at pH 6.5, the variation and increase in solubility can be even higher, as was found out when comparing solubility in fasted state simulated intestinal fluid compared to the blank buffer, or other parameters were exactly the same. So it is recommended to use bile salts and phospholipids of any type and concentration that are representative of the standard fasted state media, whether this is FASIF version 2 or FASIF version 3 for intestinal media, and FASGF for gastric media. The solubility of lipophilic compounds of log D above 3 should always be assessed in passive any version rather than simple buffer, because the presence of bile salts and phospholipids in that media will significantly increase the solubility. And if we want to have the more realistic estimation of the actual solubility in vivo, we should always test it in the medium that contains bile salts and phospholipids. One caveat is that no single type and concentration of bile salts and phospholipids will provide the best forecast of solubility in the fasted state human intestinal fluid for all drugs. This is the end for today's presentation. Thank you very much and see you next time. Bye bye.